and welcome to 13.4, Changes of State. In this particular podcast, we're going to talk about the different terms that we use for different changes of state, and then we're going to also look at diagrams that show the different temperatures and pressures at which these solids, liquids, and gases can exist. All right. So first of all, let's go through a couple definitions. Good, we got the pen working again. As you go between the various states, say we're going to, let me change this up a second, get a different color here, let's go with black. We're going between, say, a solid and a liquid and a gas. And obviously, again, we're not dealing with plasmas here. We have different names for these different phase changes as you go between these three phases. You know most of them. As you go between, say, a solid and a liquid. If you go from a solid to a liquid, that's melting. All right. And if you go between a liquid and a gas, you know that as boiling. And we're going to change colors. Let's go to a blue color because we're going to be cooling these down now. As you cool a gas down into a liquid, that process is called condensing. And as you cool a liquid down into a solid, that process will be freezing. And you know, you've obviously heard those four terms before. Now, there's a couple other terms that you may not necessarily be familiar with, such as going directly from a solid to a gas. Directly from a solid to a gas without ever passing through the liquid phase. That is actually called sublimation or subliming. And we'll be showing you different examples of that in class. Dry ice is called dry ice. It's frozen carbon dioxide. It's called dry ice because that frozen carbon dioxide turns directly into gaseous carbon dioxide without ever turning into a liquid. And you can actually go back the opposite way. We'll do this in purple. As you go from a gas directly back to a solid without ever turning into a liquid, that process is called depositing. You should know these six terms. Obviously, four of them you already know, but the subliming and the depositing one you'll have to remember. All right. So let's get back to our seafoam green and look at some phase diagrams. And in this particular phase diagram, I think we're going to shrink the screen up just a little bit here because it's easier to see. There we go. Here's a phase diagram that shows the various states of matter. On this portion of the graph right here, we have the solid phase. In the middle here, we have the liquid phase. And on the far right, we have the gas phase. And there's some important points on this diagram that we want to make sure that everybody's familiar with. First of all, this point right here in the middle, number 1, that's called the triple point. Okay. Now the triple point, let me put a box around this gas so we're not confusing this. The triple point is the point at which all three phases or states exist at the same time. You can have the solid, the liquid, and the gaseous phase all sitting in equilibrium and not changing back and forth. The only time you're going to have some changes is when there's a change in energy. So that's an important point, the triple point. Number 2, all the way up here. This is called the critical point, or the critical temperature. That's the point, or that is the temperature above which you cannot change something into a liquid. Above that temperature, so I'll just say above which a liquid can't exist. No matter how hard you squeeze or apply pressure to that gas above that temperature, it will always be a gas. All right. Now the other points on here, number 3, point 3 here, this is the point at which phase changes are going to be occurring. And number 3 here, anything along this line, including number 3, you're going between solid and gaseous phase. So if you go in this direction, you're undergoing sublimation. And if you go back the opposite way, you're undergoing deposition or depositing. If you look at the number 4 right here, okay, and anything along that line, that's the barrier of both melting if you go from a solid to a liquid, or going in the opposite direction, you have freezing. And then obviously anything between points 1 and 2 along this line here is going to be boiling, and we're starting to fill up our screen here, or condensing. So here's a phase phase change. Anything in that area, along that line. Anything along this line deals with freezing and melting, and anything along this line deals with sublimation and deposition. Okay, so you can actually predict the actual phase of a particular substance depending on the temperature and the pressure, or you can also predict what would happen to a particular substance if you increase or decrease the pressure and the temperature, and that's what we're going to look at in the next podcast.